We will study cladistics in this class, and finally it will be linked with the stratigraphic studies. Clados spelled in this way or that way means the branch, and cladograms involve nodes or vertices and edges or branches. So, in one way the cladogram can be compared with graph, and when we are studying the fossil assemblages, from there we can find out the sister species. We will see them in the course of study. Cladistics is a method of classification that groups taxa hierarchically into discrete sets and subsets. So, in this definition there is no time connotation. In this definition there is no discussion on the evolution of organisms. Let us read the definition again. Cladistics is a method of classification that groups taxa, grouping of taxa will be done hierarchically into discrete sets and subsets. So, there will be set of taxa, and within that there will be different subsets of taxa. Interestingly, cladistics can be used to organize any comparative data. For example, even in linguistics, but we are not discussing that here. Its greatest application lies in the field of biological systematics, therefore also in paleontology. The pioneering worker on cladistics was Willy Henning, and his concepts are known more popularly as the phylogenetic systematics. Henning's approach in terms of phylogenetic systematics was to implement Darwin's concept of ancestors and descendants. Darwin provided the theory that from ancestor the descendants have come, from ancestor plant to descendant plant, and from ancestor animals to the descendant animals. What is the aim of cladistic analysis? The aim is to hypothesize the sister group hierarchy and express the results in terms of branching diagrams. We are going to see, and these diagrams are known as cladograms. The purpose is to present the different units, also known as clades. Through cladistics, we show that there can be two taxa are more closely related to each other than a third one, and this is the fundamental of cladistics. And the statement that there can be two taxa which are closely related than a third one is known as the three taxon statement. Here is a cladogram, and in addition to that a time connotation has been provided. We are taking the present day four animals: lamprey, shark, salmon and lizard. Salmon and lizard came from a common ancestor X. Now, when we present in this way, this X might be known or unknown. So, it can be known by paleontologist or it can be a hypothetical, same with the taxon Y and the taxon Z. So, it is a cladogram with additional time axis added. Says at time t0 the Z taxon evolved and gave rise to two taxa. One is the lamprey, another is the taxon Y. At time t1 taxon Y gave rise to two taxa, one is the shark, another is the taxon X. At time t2 X gave rise to two taxa, the salmon and lizard. So, we can group salmon and lizard as B plus C since they have a common taxon. We can also group shark, salmon and lizard as A plus B plus C since they are coming from a common ancestor Y, or we can also group lamprey, shark, salmon and lizard as A plus B plus C plus D here because they come from the common ancestor Z. So, when we refer the term group, this was the meaning. B plus C can be one group, A plus B plus C can be another group, and A plus B plus C plus D can be the other possible group. Let us define the term clade. Two or more than two species, or I can write here taxa, that define a common ancestor with other descendants of that ancestor form a clade. The way to write by bracket is that since A and B come from a common ancestor, I can write AB and then bracket. Then I write C here, they come from a common ancestor, so I can close the bracket. Similarly, at other side I can write D and E within bracket, and all A, B, C, D, E come from a common ancestor, therefore, everything can be put inside a bracket, and this is the presentation here. What are the sister clades? Two clades having a common ancestor. For example, A, B, C and D, E have a common ancestor. Therefore, A, B, C and D, E can be called as the sister clades. We can follow this simple statement: species A and B are mutually most closely related because they come from a common ancestor, as are D and E, D and E. Now, species C, this one is more closely related to A and B. Why? Because C and the AB's common ancestor has a common ancestor. That is what is stated, is closely related to A and B than to D and E. The presentation of the different taxa using nested parenthesis is like this, which I have already explained here. We have to understand two terms, plesiomorphic and apomorphic. Plesiomorphic means the character or state that occurs in the ancestral morphotype, and apomorphic means the derived characters or the states. These states or characters can be the physical feature or the behavioral pattern of the different taxa. When I compare the two taxa B and C, a character that occurs in the ancestral morphotype here is given by small a. Therefore, the character state A is plesiomorphic. From this morphotype, another taxon has come and a new character A dash is produced. Therefore, A dash is called apomorphic. Now, what about this diagram? In this case, character state A is plesiomorphic with respect to A dash, and the character state A dash is apomorphic with respect to A, but when I compare A dash with A double dash, then we say that character A dash is plesiomorphic with respect to A double dash. So, when we try to find out the sister groups, they are discovered by identifying the apomorphic characters. The shared apomorphic characters known as the synapomorphy, these are the structures inherited from the most recent ancestor. Characters unique to some species or groups are called the autapomorphy. Let us look at our first example, lamprey, shark, salmon and lizard, and how the different characters can be placed. Characters 1, 2, 3 and 4 are the synapomorphies, whereas characters 5 to 9 and then 10, 11, 12 are the autapomorphies. If the evolution has gone in this way, then C lizard, B salmon, A shark and D are the terminal taxa. Character 13, development of fin rays in shark and salmon probably happened independently. Now, if we look at that property of shark and salmon, that they have fin rays, it will be incorrect to group A and B. Cladistics analysis orders the synapomorphies into nested hierarchy by choosing the arrangement of the taxa that accounts for the greatest number of characters in the simplest way. This is important and we will see what is the meaning of this simplest way. Character 13, as I was telling, fin rays can be found in shark A and in salmon B. So, if we group A and B on the basis of fin rays, that means character 13, it does not mean A and B come from a, one has to be alert when it is said that they do not come from the same ancestor. In one sense it is true. For example, shark and salmon are not immediately coming from the common ancestor. Shark is coming from the taxon Y, salmon has immediately come from the taxon X, but it is also true that X and Y actually came from the common taxon Z. So, one has to be alert. We can have two alternatives A and B, where the characters 1, 2, 13, 3, 4, this and that have been considered. As per option B, salmon and lizard had a common ancestor from where they came, whereas as per option A, salmon and lizard do not have an immediate common ancestor. For example, in fact, salmon and shark got an immediate common ancestor. Which cladogram is more preferred and is parsimonious? In option B, characters 3 and 4 appeared only once. Here is 3 and here is 4, whereas here 3 and 4 had to come 2 times. So, given a choice, this cladogram will be more preferred. But this does not mean exactly in this way evolution has happened. Important. Let us recollect these two terms. Plesiomorphic, the character or state that occurs in the ancestral morphotype, and apomorphic, the derived characters or states. Consider 4 taxa A, B, C, D, and the number of characters is 6. Now, here the open boxes will indicate the plesiomorphic characters. For example, taxon A has the plesiomorphic character 1, 2, 3, 4, 5 and 6, and the closed boxes, the black boxes indicate the derived characters or states which can be found for character 1 is present in B, C and D, character 2 is present in taxon B, character 3 is present in taxa C and D, character 4 is present only in taxon C, character 5 is present in C and D, and character 6 is present in B and C. This is the information a paleontologist can gather. Now, the question is, how do we do the grouping? These are the 3 possible groupings presented. To do that, one has to visualize different ways of assigning the characters. So, we are basically moving from the taxon matrix or the character matrix, this matrix, towards the cladogram. Now, here characters 2 and 4 can be called autapomorphy, since they are each present in only one of the taxa. Character 2 is present only in taxon B and character 4 is present only in taxon C. Since they are present only once, they will not be useful to group the taxa. So, the autapomorphies are not useful to group the taxa. To group, we need the shared character between 2 taxa, and in this case what has happened, character 2 is only present in B. I do not find another one, so that I cannot say character 2 is present in B and something else, that something else is missing. Same point with character 4. We find that characters 1, 3, 5 and 6 are present in more than one taxa. Character 1, 3, 5 and 6 are present in more than one taxa. So, this gives a chance of grouping the taxa. There are 3 ways in which the taxa can be arranged, given by the figures B, C and D. Out of these, figure 1.5e, which is same as this figure B, is the most parsimonious solution, since in this case a single character, character 6 is repeated only once. Character 6 is repeated only once. Look at the other cladograms. Here character 6 is repeated, character 5 is repeated, character 3 is repeated. So, it is not a favorable solution. And in case of figure G, characters 3 and 5, 2 characters are repeated. So, there is single repetition in case of option E, or in other word the figure B. So, this is the most parsimonious solution. The distribution of characters can also be thought of as the number of steps on a cladogram. In figure 1.5e, the number of steps is 7. Why? If I count the black boxes, there are 7 times that it has come. There are total 6 characters and their appearance is 7 times. The other cladograms are more costly, because in figure 1.5f, in this figure, if I count the total number of black boxes 1, 2, 3, 4, 5, 6, 7, 8 and 9. So, it is 9, and in case of figure G, it is 1, 2, 3, 4, 5, 6, 7 and 8. 9 and 8 are considered more costly and less preferred than this number 7. Therefore, figure 1.5e, that means this figure is the optimal cladogram. This term is found, optimal cladogram, and the other 2 cladograms are the suboptimal cladograms. For example, figure F and G. Let us look at a new example of a taxon or character matrix, the data matrix. We have the 5 species A, B, C, D, E, and we are dealing with 5 characters 1, 2, 3, 4, 5. Character 1 is present in species A to D and is absent in species E. Similarly, you can read the characters 2, 3, 4 and 5, for which species they are present and for which species they are absent. This term species can be generalized by writing taxa. Here we use the term character data 0, which is present many times in the matrix, is the primitive state, and 1 is called the derived state. 1 also can be found within the matrix. Now, 2 possible cladograms can be considered. This is one and this is the other, given by figures B and C respectively. Character 1 developed here and it did not develop in species or taxa E, and as you see, character 1 does not exist in species E, that is why is this placement. Then from this common ancestor, from this point we can think that character 2 got added up and is shown for species A here, it is present, whereas in species B 1, 2 and 4 are all present. In species B 1, 2 and 4 these characters are present. In case of species C, characters 1 and 3 are present. Here C, I find character 1 and character 3 are present. In case of species D, 1, 3 and 5 are present. Here is species D and we see characters 1, character 3 and character 5 are present. Let us look at the second possibility. Here, since E has got no character, character 1 starts from here. Now, what happened in species D? Characters 1, 3 and 5 were found. In case of species B, characters 1, 2 and 4 are found, and in case of species C, 1, 2 and then we find within bracket 2 and then 3. This within bracket 2 means character 2 going out, 2 some character developed, that is going out. Within bracket if I write something, that means character going out. In species C, indeed character 2 has gone out, that is why it is 0 shown here, and that is why a bracket is given. What happened in species A? Characters 1 and 2 are there. In species A, characters 1 and 2 are there. Now, by doing these 2 possible cladograms grouping, we are finally saying that this is the most parsimonious solution, because here we utilized each character only once, whereas here we not only utilized each character once, but then we had to delete one character. Since that extra step is required, this is the suboptimal cladogram, and this one is the optimal cladogram. Once we have written the number 1, 2, 3, 4, 5 etc. on the edges, they are called the novelty or the novel state of characters. Writing within bracket, as I told you, means that character 2 got its the primitive stage, that means from 1 it has become 0. Anything written in bracket will mean from the derived state it is going to the primitive state. Cladogram B, that means our optimal cladogram, has 5 postulated evolutionary transitions. What are they? 1, 3, 2, 4 and 5. 5 times each of the novelty has been added up, whereas in cladogram C total 7 postulated evolutionary transitions are there. What are they? Let us count 1, 2, 3, 4, 5 and 6, and then this within bracket 2 is also counted. So, there are 7 postulated evolutionary transitions. So, this is more costly, hence less preferred, and this one is less costly and therefore, it is preferred. The number of transitions in a cladogram is called the length of the cladogram. So, in case of cladogram B, the length is equal to 5 and the length of the cladogram C, LC length is equal to 7. As I was telling earlier, there is no guarantee that evolution always followed a parsimonious cladogram. There are computer programs available to find out the optimally parsimonious cladogram from a large data set. Here we are doing simple exercise with minimum number of taxa and minimum number of edges in the cladogram just to understand, but when the data set is large, there are computer programs available to work. Let us take another example. Now, we are increasing the number of characters, 7 characters, and the number of species are 5. In our earlier matrix, it was a square matrix. Coincidentally, there were 5 species and 5 characters. So, now we are dealing with a non-square matrix with 5 species and 7 characters, that means 7 columns and 5 rows. Let us define the term character pattern. 1 is a character and its pattern for the 5 species is 1 1 1 1 0 is given here. So, if this column is written in this way, this is known as the character pattern. Let's write down the character patterns for 2 to 7, these characters 2, 3, 4, 5, 6 and 7. Even after defining such a matrix, a paleontologist can rely more on certain characters and less on certain other characters. Therefore, he may decide to drop a few characters in building the cladogram. Consider figure C, where all the characters have been used 1, 2, 3, 4, 5, 6, 7. All these numbers can be seen in the cladogram. That means, no character has been removed. This can be a paleontologist's choice. But if I decide to drop characters 2 and 7, there can be ways in which the grouping can be done. Just to give an example, species E has got none of these 1 to 7 characters. So, I have drawn it like that, and species A has got 1, 4 and 3 these characters 1, 4 and 3. What happened to character 2 and 7? As I told just now, character 2 has been dropped. So, this 1 is not counted anywhere and we do not see 2 and 7 anywhere in the edges. So, even if here is 1, that means character 2 is present, character 2 has been avoided. Character 7 anyway was absent here and therefore, character 7 does not come for species A. In this way, look carefully the matrix and tally each of these species characters. This also means a cladogram created by a paleontologist with all the characters used might get revised in future when another paleontologist understands that certain characters need to be dropped. So, in that case, the cladogram is to be revised. An exercise for the students: for figure B, the 5 possible cladograms are given. Can you assign characters 1 to 7 within these cladogram edges. Let us take another example. Consider this matrix. Character 1 is present in A, B and C given by these black boxes. Here the white boxes indicate that character 1 is not present in the species D and E. Similarly, character 2 is found in species D and D and is absent in species A, B, C. So, instead of 0 and 1, we are using boxes of this kind of appearances. A white box will mean 0, that means absent, and 1 is given by a shaded box. The plesiomorphic states are indicated by the open boxes and the apomorphic states are shown by the solid boxes. One interesting observation is that when we consider the two characters 1 and 2, when character 1 is present in some species, character 2 is absent, and for species when character 2 is present, there character 1 is absent. Therefore, the characters 1 and 2 are said to be consistent or logically consistent. That means they are consistent to discriminate taxa group, or they are logically consistent to discriminate taxa group. So, I write here logically consistent to discriminate. Now, let us consider character 3. Character 3 is present only in B and C and is not present for the other taxa D, E or A. Therefore, B and C can be called as a subgroup of the group A plus B plus C. B plus C becomes a subgroup. So, if I look at it once again, A, B, C can be called as a group because taxa 1 is present in them which is absent in other. Now, we take special notice to character 3 which is present only in B and C. So, in A plus B plus C group, there is a subgroup of B plus C. Now, let us take a special attention to character 4. Character 4 also appears in taxa A, B and C. Character 4's appearance and character 1's appearance are the same. Character 4 is found in taxa A, B and C. Character 1 is also found in taxa A, B and C. Character 1 is absent in D and E. Character 4 is also absent in D and E. Therefore, characters 1 and 4 are called the congruent to each other. That means, the argument that I will make with character 1, same argument of grouping can be done also with character 4. So, with this much of discussion and from that data set, it looks like we are able to make two groups A plus B plus C and then D plus E. Now, the problem comes once we look at character 5. Character 5 is found in C and D. Character 5 is found in C and D. So, it conflicts the concept of the two groups, two major groups A plus B plus C and D plus E. Since it is conflicting, we can call it the conflicting character or a homoplasy, which can be found in this data matrix. Whatever I have discussed here, step by step, first A, B, C was considered as a group and D plus E was considered as a separate group. So, in the first step, we can make a primitive cladogram like this, where A, B, C have a common character 1. Then we thought of D and E as the second group. D and E have been brought here and character 2 is brought here. So, based on whether character 1 is present or character 2 is present, two groups are made. Next step, what we did, we said that within A plus B plus C, B and C has a common character 3. So, a subgrouping is done and this portion remains the same. We found that character 4 and character 1 are supporting each other. So, beside character 1, character 4 is placed. No new groups are made, that character 4 is supportive of character 1. This particular statement, that there is a congruency noted. Next, we added the character 5 as the conflicting character here and here. In this way, progressively the cladogram is prepared. This is the end product. We already classified the characters into consistent, congruent and conflicting, and these boxes are therefore used progressively starting from figure B up to figure F.